है a constant force F equal to m2g by 2. So this F is m2g by 2 is applied on the block of mass m1 as shown in figure. The string and the pulleys are light, surfaces of the table is smooth. Find acceleration of m1. Okay, so here also we have two objects, but this is not on incline. So what we will write is, we will write the same process we will apply. We will first identify the two objects, then we will write their forces, we will write free body diagram, and we will write their equation. So first for m1. So for m1, what are the forces for m1? For m1, if you write, see, this is tension will act in this direction, and here also tension will act. So tension is acting like this, then its weight m1g, and since it is pressing the table will also exert an upward normal force. So suppose this is n. Okay, so vertical direction normal and m1g, horizontal direction tension and F. Okay, so and another one we have this one. Okay, this object. Okay, so for this object we can write only two forces, that is m1 m2g and tension, only vertical force, there is no horizontal component. Okay, so in which direction this object will move? So you can see that F is half of m2g, the less than weight. F is less than the it is half of the weight of hanging object. So object is going to slide down. The F will not be able to move this object on the incline. Okay, but whatever, we can assume any direction. We can assume even in the last question, you could assume the opposite direction. So suppose we do not know exactly in which direction object is going to move. Suppose we take that acceleration is like this. It is going to move up, and this one is going to move leftward. Okay, our assumption may be wrong, so it will be while solving it will be clear. So this object is assumed to be moving up, and the upper object is assumed to be moving leftward. So the equation which we will write, the free body diagram is what we have shown in the above diagram only. So m1g, then normal, then force, then tension. So for finding equation, we need to write equation along horizontal. So along horizontal, if you write along horizontal, equation along horizontal. So along horizontal, what equation we can write? Since we are considering the object is moving leftward, so we have to take F larger, tension smaller, then F minus T, that is total force, equal to MA. So M1 into A. So this is equation 1. F equal to MA. So total F is what? F rightward and T leftward. So F equal to MA. Okay. Similarly, we will do for other objects. So for M2, we have tension up and M2G down, and the system is going up. So we will write tension up minus M2G down, that will be equal to M2 into A. So F equal to MA equation we have used. Okay, so this is equation 2. Now for finding acceleration, what we can do is we can add these two. You can see the tension will get cancelled. So adding 1 and 2, if you add equation 1 and 2, you are going to get tension will get cancelled. So F minus M2G is equal to M1A plus M2A. Now how much is F? The F is M2G by 2. The F is M2G by 2 minus M2G equal to A M1 plus M2. Okay, so after this, what we can do is A is, if you solve it, you will be minus M2G by 2 and divided by M1 plus M2. Okay, so this much acceleration we are getting. This is the acceleration of the two objects, and we are getting minus sign here. So what this minus sign is indicating? The minus sign is indicating that the assumption which we took, that the M2G is going up and the upper object is going left, that is just opposite. The actual acceleration is just opposite to that. So the minus sign is indicating that M2G is coming down and this upper object is going right. So the acceleration we can write, the acceleration is M2G divided by to m1 plus m2 acceleration is this much, and in which direction? For m1, if we say it will move rightward, that will be rightward. Okay, so this will be our answer. This is the acceleration in rightward direction.